Hi there, and welcome to the content highlights for Chapter 12.1 and 12.2. In these sections, we will explore frequency tables, constructing them, as well as using a histogram to find the mean, median, and mode of a set of data. A random sample of 30 college students is selected. Each student is asked how much time he or she spent on homework during the previous week. The following times in hours are obtained. Construct a frequency table with the data. The first thing that is very helpful in order to construct a frequency table is if your data is not already given from lowest to highest, it's recommended that you first list those out in ascending order. What this will do is make the list much quicker to be able to count upward. So off to the side here, I'm going to make a list from low to high. Now that we have taken a moment to list our values in ascending order, we see that we have a minimum of 15 and a maximum of 25. So in order to construct our frequency table, we're going to go ahead and set up our list, the time it takes, and then the frequency associated with each of those. Now we need to list everything out between 15 and 25, and then we'll count up how many of each that we have. As we can see here by counting, we have a frequency of 2 students who said that it took them 15 hours to study. We have 3 students who said it took 16 hours. 0 students said it took them 17 hours to study. Took 4 students 18 hours to study. And then we can continue on here and keep counting those up. Now, once you've completed this comprehensive list, a way to check that you've done your work correctly is to go ahead and tally up everything in the frequency column. Since we started with a total of 30 students, that number should be the same as what you get when you take the sum of your frequencies, as you can see we have here. Next up, let's take a look at calculating mean, median, and mode based off of a histogram. Given in this chart are scores and the frequency in which they occur. The trickiest in something like this to calculate is actually the mean, so let's do that one last. The mode is calculated by the highest frequency. So in this case, we're going to look on our chart and see where is the highest frequency. We can see that that occurs at a score of 12. So this time we can say that the mode is 12. And of course, with a frequency of 7, no other category has that same exact frequency, therefore it is just a mode of 12. The median, however, is calculated by the centermost value. Now, in order to do this, we need to know first how many pieces of data do we have. Here we have a frequency of 1, 6, 7, 6, and 1. And adding all of that up, we see that we have a sample size or total number equal to 21 here. So that means that to get the median, we have to go halfway, which puts us at 10 and a half. So if we calculate 1 plus 6 is 7, that's not quite at 10 and a half yet, so we have to then go into the next category, which lands us, as we see, back at 12 again for our median. Another way you could calculate the median would be to take this histogram and list all of your values out from lowest to highest, and then of course cross out on either side until you get to the center. While that works nicely with a list of data, it's a little bit more cumbersome to accomplish when you're working with a histogram. The third method that we're going to look at in central tendencies is the mean. When calculating the mean of a set of data like this, it's essentially the same thing as having a frequency table. You have your score, which sometimes you refer to as x, your data value, and then you have, of course, the frequency. Now remember, the mean of anything that has frequencies to it, so in this case a histogram or a frequency table, they are interchangeable in this context, is going to equal each score times its respective frequency, and we add those up. So the mean here is equal to the score of 10 has a frequency of 1 plus the score of 11 with a frequency of 6, score of 12 and 7, 13 and 6, and 14 and 1. And of course, a mean means you divide it up by the total, which earlier we found was 21. This gives us 252 in the numerator. Multiply first, then add them all together, divided by 21, which coincidentally is also equal to 12. This is something which we'll learn about a little bit more in the subsequent sections. That's referred to as approximately a normal distribution because it has this little bell shape to it. So stay tuned for more, and thanks for watching.